You've stood in shallow water before. A tide pool, a reef on vacation, the edge of a harbor, sunlight cutting down through 6 feet of water. And somewhere near your feet, close enough to touch, something has just gotten hotter than a blowtorch, hotter than lava, closer to the surface of the sun than to the water around it. No explosion, no flash you could see, no warning at all. Just a small lopsided shrimp, sitting in a burrow, closing one oversized claw. That's it. That's the whole event, and it happens millions of times a day, in shallow water all over the planet, close enough that you have probably swum right past it. Most people assume the ocean's most extreme, most violent physics happens somewhere far away. Deep trenches, hydrothermal vents, crushing pressure, total darkness, thousands of feet down. That's not quite right. And the real answer is far stranger than that. The most extreme temperature event most of us will ever come within arm's reach of isn't hiding in the deep ocean at all. It's sitting in ankle-deep water, wearing a shell, and it's smaller than your thumb. The animal is the pistol shrimp, sometimes called the snapping shrimp, found on reefs and shorelines worldwide. For over a century, biologists knew something was strange about it. It has one claw that looks almost normal, and one claw wildly oversized, like it borrowed the wrong hand from something twice its size. When that big claw snaps shut, it makes an unusually sharp, loud click, and small fish nearby sometimes simply stop moving, stunned, sometimes killed, and the claw never touches them. For decades, nobody could fully explain how a snap that fast from an animal that small could do that much damage without contact. Here's where it gets stranger. In the year 2000, researchers Michel Versluis, Barbara Schmitz, Anna von der Heydt, and Detlef Lozi finally caught the motion on high-speed cameras fast enough to see what the human eye never could, and published what they found in the journal Science. The claw doesn't just snap shut. One half slams forward and fires a jet of water ahead of it at roughly 25 meters per second, fast enough to cross a swimming pool in about 2 seconds. That jet moves so fast it does something water isn't supposed to do. It drops the pressure in front of it below the point where water can stay liquid at all. And for a fraction of an instant, a pocket of pure vapor tears open in the water. Not a bubble of air. A hole where the water used to be, held open by nothing but speed. But that's only half the story. And honestly, what comes next is even stranger. That hole doesn't last. The surrounding water rushes back in immediately and crushes it. And that collapse, called cavitation, is the actual weapon. Not the claw, not the shell. A hole in the water, punching itself shut. The shockwave from that collapse is loud enough to stun or kill prey several body lengths away, registering by some measurements above 200 decibels, among the loudest sounds produced by any living animal on Earth. Louder than a gunshot. Loud enough that entire colonies of these shrimp have reportedly interfered with underwater sonar equipment. A creature you could hold in your palm, generating a sound that can rattle machinery built by navies. But there's another layer to this, and it might be the strangest part of all. The same collapsing bubble that produces that shockwave also, for one impossibly brief instant, spikes in temperature. Versluis and Lozi's measurements put it at somewhere around 4,800 degrees Celsius. The surface of the sun sits at roughly 5,500 degrees. For a span of time too short to properly picture, in water shallow enough to wade into, a shrimp's claw closes the distance to a star's surface temperature down to a few hundred degrees. Then it's gone, absorbed back into the seawater, before it can do anything but crush whatever the shrimp was hunting. And then, in 2001, Lozi and his colleagues published a follow-up in the journal Nature, reporting something almost nobody had thought to check for. That same collapsing bubble also gives off a tiny flash of light. Not visible to the naked eye, far too faint, but real, measurable, detected by sensitive instruments, born from the exact same violent instant as the heat and the sound. They gave it a name, shrimpoluminescence. Heat, sound, and light, all generated at once, by accident, by an animal that isn't trying to do physics, it's just trying to eat. Which raises an uncomfortable question. If something this extreme, this close to the surface of a star, has been happening constantly, worldwide, in water shallow enough for children to stand in, for as long as pistol shrimp have existed, and nobody caught it until the year 2000. What else is happening right now, at a scale too fast or too small, or too ordinary looking for anyone to have thought to look? How much of what surrounds you every single day, dismissed as background noise, as nothing, is actually this violent, and you simply don't have the eyes for it? So here's what actually happens every time that claw snaps shut. It isn't a bite, it isn't a strike, it's a shrimp tearing a tiny hole in the water itself, and then watching that hole get crushed shut with enough force to touch a temperature that belongs to stars, not shorelines. It isn't a myth, it isn't exaggerated for a nature documentary. It's a measured, published, peer-reviewed fact, sitting quietly in tide pools most of us have swum past without a second thought. The next time you hear a faint crackling sound underwater, at an aquarium, on a snorkeling trip, at low tide with your feet in the mud, that sound isn't nothing. It's a creature smaller than your thumb, casually reaching temperatures that would make a blowtorch look unimpressive, and going right back to doing it again, a few seconds later, like it's nothing at all.